Alright, recording has started. So I'm going to give you just 30 seconds more. Okay, and I'm going to start with B because that's the simplest one. If it's shifted down, h of x is a height. All the heights have 2 units subtracted from it. Now, if it's shifted to the right, you take x squared, but we think of f of x as this form, and I'm going to replace the x with something here. Now, this is called a horizontal transformation when it goes left or right. And right is the positive horizontal direction, but in horizontal, everything works backwards. We get this. Okay, now, I know that this one is right, because if I was graphing this, just making a table to graph it, what I would notice is that this side, this whole side over here, is always positive. Or 0. When you square something, you can't get something negative. And so the very smallest height I could ever get is 0. And where will that occur when x is 2? So normally, the normal parabola, y equals x squared, is like this, where the lowest point is the vertex. Here the vertex has been shifted over 2 units to the right. And it's looking like this. Okay. And then reflected across the x-axis. This is also a vertical transformation. Instead of going up, it just comes down. All the heights that were positive have just become negative heights. So we take like a height right here, which might have been like positive 2. It's now coming down and negative 2. So everything comes down like this. And then vertically stretched by a factor of 4. We get this. Now, every height becomes 4 times as high as it was before. But a height of 0 stays at 0, but all these others become 4 times as high. So this one would become something like this. Be skinnier. Whatever height you had, you come 4 times as high. Alright, so give me a little feedback on number 1, nailed it or still working on it, and which part is the hardest for you, A, B, C, or D. Type that up, but don't hit enter quite yet. Okay, go ahead and hit enter. And And, oh, something else. So a student was telling me in another one of my classes that starting about maybe a week ago, the internet connection got much worse during this class. That prior to that, he said, internet connection was good and he was being able to view everything, but in the last week, it's been, especially the screen getting stuck, images getting stuck, making it very difficult to follow. How many would agree with that? If y'all could give me a little feedback on this. I've been talking with Comcast and we're trying to see if there's something in my end. And if it's different, tell me how it's different for you. So in the last week, yeah, and some people have been telling me that they just have to get off and then just watch the video afterwards, and that's totally fine. Alright, so the other thing is at the end of class today, I need your feedback about how today went, because the first step in talking with Comcast was they sent a reset signal to my modem, and so that's been done, and they need some feedback to see if that fixed the problem or not. Wow, sometimes it's both. Okay. Alright, so I'll be asking for this feedback again later today, but generally it looks like a lot of people are agreeing that in the last week it's been worse. And another thing that's happening that is I teach an evening class and they're not having the issues that we're having. And my son is taking a morning class and he's not having these issues. He has these issues right in the middle of the day in his kind of mid-afternoon class like this, anywhere around noon. And is anybody else having that experience? Because it may be that maybe, Santa Fe is online. All the students are at school online in the middle of the day, and that's bottlenecking for the whole city. Okay, and let's see. Okay, the whole day has been consistent. Okay, so it's okay. All right. Well, let's go back to number 2. Write the function h of x, same as f of x, but vertically stretched by a factor of 2, shifted left 5 and up 1. Then draw h of x. Okay. And I'm going to put something in here. Draw f of x with a dotted line. Well, let me type this. Okay, so f of x is going to kind of be your reference, and then h of x will be the main thing that you're drawing. Okay, 30 seconds more, and I'm going to give you a little more time after I write the function down. Okay, so h of x, let's go, it's vertically stretched by a factor of 2. So now every height just became twice as high. Shifted left 5 units. Now, if that's the case, we have to replace x with something, and up 1. Now, when we shift left 5 units, left horizontal, so replace x with, but it's always opposite direction. Left is the negative direction, so you do a plus right here. So this is the new h of x. Now, when we draw this, I'm going to draw f of x. It's the upper half of a sideways parabola. As x gets bigger and bigger, the height, you move out, you go up, but you don't go up at a 45-degree angle. When you're out to 9, you're not up to 9. When you're out to 9, you're only up to 3. When you're out to 25, you only go up to 5. Out to 100, you only go up to 10. So it rises kind of slowly over here. All right, so this is f of x. And then sometimes we call it y equals whatever the f of x line. Okay, and then the other one, h of x, let me give you a little bit more time to now make an attempt at drawing h. Even if you're not sure, make a guess so you can see where you're right and what part of it you're wrong. Okay, 15 more seconds. All right, so here's my f of x curve right here. My h of x, it tells me all the different ways that the graph is changed. Vertically stretched by a factor of 2 means every height becomes twice as high. So if there was a height up here, it's going to be, so it's going to arc out taller. But it also has shifted left 5 and up 1. Well, how do I shift everything left 5 and how do I shift everything up 1? I'm going to do this part first. And all I'm going to do is shift one key point. So the key point is where this thing starts. Looks like at the origin. So we're going to take that one key point and shift it left 5. 1, 2, 3, 4, 5. Oops, don't make a dot. Left 5 and up 1. That's the key point. Now, I'm going to make the same shape here, except it's going to go twice as high because it's vertically stretched by a factor of 2, like this. Okay, so the whole thing kind of, I think of it as a piece, and I typically, when I do my shifts first, left and up or whatever, and then I only shift one key point, and then I make the whole graph. Alright, give me a little feedback on number 2. Nailed it, still working on it, and was it easier to come up with the function or the graph? Which is the, which part do you need more practice on? And type that up, but don't hit enter quite yet. Okay, you can go ahead and hit enter. Okay. All right. I have a couple more practice quiz things, but I am going to jump down. I'm going to skip those for a minute here. We're going to reminder. There's a quiz 1. If you go into the modules, and if you look at your dashboard as well, some students find the dashboard very helpful. So here, let me get to student view. That's how it looks. See, way on the left, after you've gone to your course, you see this dashboard. And won't let me in with student view. Alright. Let me come back to my course. Let me get out of student view. Alright. Dashboard. And over here it kind of will, what's the stuff that's due that's coming up. Now this has for a whole bunch of classes that I'm teaching over here. Right, so for yours it's going to be a little different. Right. But you can also go down, but where you find it then is in the modules, and you'll find the quiz. And so that's due tonight by midnight tonight. Just a reminder of that. And alright, what I wanted to do today is, before taking questions on homework, I want to go back to transformations of functions. We didn't finish that last time on Thursday. So let's go back and finish up transformation of functions, and then we'll see if that might resolve some homework questions. And then we can go on to new material after we finish this up and maybe address a couple homework questions. Alright, so we had done some transformations of functions. Alright, so we're going to come back here to number 6. So I went to 3.5 transformations of functions in OneNotes. Number 6, I had changed this. And we want to work through this now. So it says, A cell phone plan costs, and I changed the numbers, $4 per month plus $2 per hour. Write the function equation and then graph it. And let me give you a little bit of time to do this. Okay, go into your group and type in, not the graph, because that'll be take too much time to upload a graph, but just type in your function equation and look at what others in your group are submitting for the function equation. And a reminder, group leaders, make sure your group knows who's the spokesman for today and be ready to step in if like their mic is out or having some trouble. All right, group 2, what do you have? Anybody in group 2? Okay. How about group 3? I can barely hear you.
One equals
Okay. Your connection somehow isn't enough for me to be able to hear you accurately. Let's go here. The function equation is, now this only happens once. This as many times as the hours used, so it has to be multiplied by the number of hours. (2x plus 4), and then if I graph that, it would be y-intercept of 4, slope of 2, so notice that it's rising 2, running 1, rising 2, running 1. And it looks something like this. Okay. And that's, I think I mentioned this last time, this is the kind of cell phone plan that my mother, who's 91 years old, would do. Is, since she hardly uses her cell phone, she'd want to pay by the hour. Part B, for each of the following. First, create a new graph. Draw it on the same grid that contains your original graph. Then write the old function equation. What you do to get the new function, label the transformation. So we're going to do part 1. I'm going to do this with you to make sure that you understand the directions. Okay, we'll modify the cell phone plan that costs $4 per month plus $2 per hour. Right, so the original equation is the one we just had, right up here, y equals 2x plus 4. Now, it says add $2 to every monthly bill, no matter how many hours were used. So now the new equation I'm going to put this extra +2 on there. So it's add $2 to every monthly bill, no matter how many hours were used. This takes this one and then it transforms it. So it says, draw it on the same grid that contained the original graph. Alright, so, and I have this worked out down here as well. The original graph was y-intercept of 4, slope of 2, like this. This new graph, everything got 2 added to it. And so it'll have a y-intercept of 6. And it'll still have a slope of 2. But every height, this height got moved up here 2 units. It went up 3 units. Like this. Every single height got 2 more units added to it. So we shifted every single, this one up 2 units. Every single point got shifted up 2 to give us this new blue curve. Okay, so we're seeing some of these ideas of shifts and transformations, but now in a practical context. Alright, so the next one. We'll modify the new cell phone plan. We'll modify the cell phone plan that costs $4 per month plus $2 per hour. What you're going to do is double all the costs. So I'm going to write what the original equation was, and then the new equation, just like I had done. And then you're going to draw the new line on the graph up above. I'll give you a minute. Okay, type your equation into your group chat. See what other group members put down. Let me quickly check over here. All right, group 5. What do you got for this? Anything from group 5? Okay, how about group? Yes.
Said y would equal 4x plus 8.
So that's your new equation?
Mm-hmm.
All right, so the old equation was 2x plus 4, and the new equation is going to be or 4x plus 8. Okay, so when you double all the costs, now what this is then is this 2 out in front is called a vertical transformation. It's actually called a vertical stretch. When you multiply 0 by 2, it doesn't change it. 0 times 2 is 0. Height of 0 stays the same. But all other heights become twice as high as they were before. If we come up here and draw this one now, let me erase some of this stuff. Okay, so when we doubled, in the end, well, look at the height of 4 becomes a height of 8. And then all the other ones, it's now going to have a new slope. 4x plus 8 has a slope of 4. So every single height of the green curve became twice as high, and this is going to be doing something like this. By the time it goes over 1, it's gone up 4. Over 1, up 4. Fairly steep. Actually, maybe I should go even steeper. Let's do that. Let's take this. It's more like this. Okay, let's go to part 3. We'll modify the cell phone plan that costs $4 per month and $2 per hour. You're going to redraw that on the graph. You're going to give everyone 3 free hours in the month. First state the new domain, only those who use 3 or more hours that month. Alright, so this won't be really applying to people who use less than 3 hours in a month. So we'll just say that people who use 3 hours or more in a month are going to get 3 free hours. And we'll assume that everybody uses 3 hours or more a month. So come up with the equation, the new equation, draw it, and at my signal enter the new equation into your group chat. But just wait a minute. Okay, go ahead and enter your new equation in the group chat. See what other people are writing. Okay, let me ask group 1. What do you got here? This is a kind of a tricky one.
Hi. This is Brianna. I think it's y equals 4x plus 8.
Y equals 4x plus 8 with the 3 free hours in a month?
Yes.
Okay. This, how'd you come up with 4x plus 8 from the 3 free hours? Brown. Can you explain?
I'm sorry, I'm still using the old equation.
Okay. Any ideas within this new one, or you want to pass on this one?
Can we pass?
You bet. You bet. And I'm going to open this up to anybody. Anybody have a guess as to this with the 3 free hours in a month?
Would it be y equals 2x plus
2x plus, keep going?
minus 2x
Yeah? Kind of losing you.
2x 6
Plus 6?
minus
Something with the minus 3? Okay. Let's check this out. Minus 3. Maybe the 3 free hours in a month would cause there to be like a minus 3 over here. And let's see if this is right. Alright, so what I know is on the old versus the new. In the old original one, if I made a little XY table, and X is the number of hours, and this is the cost. If I did 2x plus 4, if you did 0 hours, it cost you $4. If you did 1 hour, it cost you $6. If you did 2 hours, it cost you $8. The new we're going to give everyone 3 free hours. First state the new domain. Now, the new domain, let me come to a different color here. This domain was x greater than or equal to 0. You can use 0 hours in a month. You can use any positive number. You're not allowed to use negative 3 hours in a month and get some money back or something. That wouldn't work. This one, the new domain, we're only going to consider it for x greater than or equal to 3. If you had 3 hours that you used, it's going to be as if you did 0 hours, because 3 free hours in a month. So that's still going to be $4. If you did 4 hours, the first 3 were free, and the next one cost $2, so it's $6. You did another 5 hours, it's $2 more, $8. Alright, so what we can see is when you get 3 free hours in a month, this data set of the inputs gets replaced with this data set. So you got even a new domain right over here. So the new equation, if we check on this one right here, see if this works. Let's plug in 3 right here. And so for this one, let's go back. Let's make a tiny little table here. if we had this, if you did 0 hours, you'd zero this out. 4 minus 3 is $1. Ooh, it doesn't decrease all the costs by $3. This would decrease all the costs by $3. Normally that would cost $4 and 3 was taking off your total. This decreases cost by $3. It's not quite the same as giving us 3 free hours. Okay, so this is probably a guess I would have made and checked it out. Does that work or not? But we kind of see what it's doing. It's going to give me the same output set over here, but instead of 6, it's 3 off of that, $3. Instead of $8, it's $3 off, it's $5. But what we really wanted to get was 468 at 135. So now, when we're coming up with a new equation, when the input set gets replaced with a new input set, it's going to be either one of these. Instead of this equation, the x is going to be replaced. And is it going to be replaced with, let me do it again, will it be replaced with x, so it's $3 free hours, x plus 3, or will it be replaced with x minus 3? Now, how can I tell which one it's going to be replaced with? Well, we know in the new set, if I put 3 in, I should get 4 as my cost. 3 hours in. If I put a 3 in here, I'm going to get 6 plus 2 times 2 is 12, plus 9, I'm going to get $16. That seems like way too big of a cost. If I put 3 in here, I'm going to get 3 minus 3 is 0, 0 times 2 is 0, plus 4, I'm going to get $4. I'm going to get the right amount. If I put in 4 here, I'll get 1 times 2 is 2, plus 4 is I'd get $6. Ah, this is working. This is the new equation. That we want right here. If we gave everybody 3 free hours, we get that. And let's take a look at the normal equation. Let's put that in green. The first one was had a y-intercept of 4 and slope of 2. So every time it goes to the right, it goes up 2. This new equation, I'm just going to take one key point, the y-intercept, and it shifts it 3 units to the left or 3 units to the right. Well, horizontal always goes opposite of a sign, so it shifts it 3 units to the right. It's going to start here. Okay, and then, but it also shifts it up 4. So instead of putting my mark right there, I have to shift this 1 point 3 units to the right, 1, 2, 3, 4 units up. And then I have it right here. And this is going to still wind up tilting at the same angle as the other one. So we're going to wind up getting this, but this key point here will end up shifting over to this key point. And then we get the graph, it's a line parallel to the other line. Okay. And, all right, we are at a breaking point. So let's start again. In 15 minutes, that'll be 1:33 p.m. Okay. And the new domain is x greater than equal to 3.
Mr. Shankin?
Yes. Yes, how can I help you?
Sorry. Question about number 27 on the 3.5 homework. Can you go over that really quick? Sorry.
3.5, number 27.
Yes.
Okay. After the break, that'll be the first thing I do.
Okay, sorry. I didn't.
No problem. Doing pretty good today, Pepper. All right, we will start up again. And comment was made, wouldn't it be 2x minus 2? And that is correct. When I was graphing this, I made a mistake. I totally forgot about something. When we take this, if we simplify this expression, this becomes 2x minus 6, we distribute the 2, plus 4, which is 2x minus 2. And now this one, though, doesn't start until x is 3. And then you're going to get, when you put 3 you're going to get 6 minus 2, which is 4, which is the same value as what we're getting over here. You'd get these same outputs. And so it would be 3 over 4 up this point, and then 4 over 6 up this point. So it should be this curve right here, not this other curve in here. Okay, and the only transformation that really happens is we moved to the right 3. Every single point got shifted to the right 3 units. Alright. And we had a question about this one, 27. Sketch a graph and use one of the toolkit functions. So we're going to compare. It calls this a toolkit function, the basic function, y equals x squared. And so y equals x squared would be standard parabola. And if we went over 1, we'd be with 1, and so on. And then this one, this new one, is the same as this one, except it's been shifted. This is a horizontal shift. Opposite of a sign, it's going left 1 unit. This is a vertical shift, goes same direction as the sign, down 3 units. So if we take the vertex and go left 1, down 3, that's going to be, and then it's the same shape, a parabola. It's like this. So it went left 1, down 3. Okay, we can get to more questions as well, but let me finish the some of these application-oriented problems. We'll modify a cell phone plan that costs $4 per month plus $2 per hour. Add 1 hour to everyone's monthly usage, and also include an upgrade service charge of $5. So, let me give you a minute. Okay, so let me stop you here. So if I drew for the original an XY table, we've already seen this, but if I use 0 hours, it costs me $4. If I use 1 hour, it costs me $6. 2 hours, it costs me $8. For the new equation, how should it work? Alright, add 1 hour to everyone's monthly usage. So if somebody had 0 hours, they'd be charged as if it was 1 hour. And also include an upgrade service charge of $5. So instead of just this 4, they had 1 hour added to their usage, and they had a $5 extra fee. When you put it together, 7 plus 9 is 11. Okay, so if they had 1, it would give you the same price as before, but plus an extra $2, plus an extra $5. It's, you can see it'll wind up adding $7 to everybody's thing. So now, a couple ways to think of how we could add $7. One way to think of it is this. We replace x with x plus 1. We added 1 to everyone's monthly usage fee. And then we had the normal plus 4. But then we did plus $5. Now, this, does it do it what we're expecting? What we're expecting. If we made a little table from this, if you put in 0 for x, we would have 9 plus 2, which is 11, which is matching over here. Put in 1, you'd get 2 times 2 is 4, plus 9 is 13, so this is working. So, this winds up shifting our graph. It's horizontal, goes opposite direction of the sign, so it goes left 1 and up 5. Okay. And so it would take the graph that we had before and it would shift it left 1, up 5, kind of go way up here, but let's start here because nobody really uses -1 hours, so it started at the 0 like this. All right, that's what I wanted to cover from this previous worksheet, and more questions on the homework. Anybody else have a question on homework? You can type it in. You can also just speak it in. All right, I want to bring your attention. Yes.
I have a question from the worksheet.
Mm-hmm.
D, for the first one?
So composition of functions worksheet.
Yeah.
Okay, and number 1, part D
Yeah, part D and E.
and E. Okay. Let me pull up my worksheet. Composition of functions, student homework. Alright, D and E. Alright. Horse eats 4 bales of hay per month. Each bale of hay costs $15. Okay, and then create, when we get to D, create a function h of x, whose input is the number of horses you own, and output is the total cost. Use x as your input variable. So, if you had let me do this. Go way to the bottom here. It's in. Alright, so I want my h of x. Before I do it, notice I did this, I was just doing this with my other stuff. I might make a table first. If I had 1 horse, it would eat 4 bales of hay. And each bale of hay would cost $15, and it would give you the 4 times the 15. Okay, so really though, to see all of this, we need to see the answers for the other ones. So let me kind of show you here. This function, input is number of horses you own, output number of bales of hay eaten, that's 4x. The input is number of bales eaten, output is the total cost. Each bale costs $15, g of x is 15x. And then this function, h of x, is combining both of those. So you want your h of x to be g of f of x. So h of x will be g of f of x. And the g of x was the 15x, the f of x was the 4x. And so you work through these two together right here. Is that enough to get you going on D? Does that answer your question?
I think so, yeah. Because that's what I was kind of doing, but then I got myself confused for whatever reason, but I think I got it now.
Are you sure? Or do you want me to go further?
Yeah, you could go a little bit further, I think.
Okay. So then this g of x, or so h of x will be g of 4x, and that's going to be g of anything is 15 times that thing, which is equal to 60x. Thus, h of x is equal to 60x. And what this really means is that for every horse you have, it's going to cost you $60 a month to feed it. So if I have 10 horses, it's going to cost me $600 a month. If these are accurate conditions. Bales of hay and costs per bale of hay. And by writing it out as two separate functions like this, you could adjust one as the price of hay goes up. You just have to adjust that function. And then if you get a new horse, then you just, you know, or each horse eats 4 bales of hay. Well, maybe that would stay the same. Okay. All right. Any other questions? Okay.
Mr. Shankin,
Yes.
this is Brianna.
Hi, Brad.
I have a question. I had a hard time figuring out number 44 on 3.5.
3.5, number 44. Okay. So what they're counting on you knowing, and they're assuming that you know this, is that y equals x cubed looks like this. It goes up faster than y equals x squared to the right. But to the left, it comes down slower. It's when x is negative, you're going to get negative values because it's an odd power. So y equals x cubed is kind of like a steeper parabola for the right half, but because it's an odd power, like negative 2 to the third, it's going to give you negative 8. So it gives you this. So that's the basis function for this one. And then how did it get moved around? How did that get changed around to that? Well, you see, on the left it's supposed to be going down, and the right is supposed to be going up. This is flipped around. To flip it around, you just put a negative. That would flip this part down here, and flip this part up here. So then it's starting to look like that. So there's two other things that have happened. It looks like, you know, this one key point right here has been moved to right about here. So that looks like it's moved 1.5 to the right and maybe 1 up. So to move it 1.5 to the right, you replace x with x. Now, to move to the right, you have to use the opposite sign, minus 1.5 cubed. And then, to move it up 1, you go like this. Brianna, does that answer your question? So this one,
Yes, thank you.
you're welcome. So this was one of the base functions that we hadn't gone over. So that's why it might have been a little unfamiliar. Okay. And all right, any other questions? All right, I want to shift now. We're gonna let me talk about, today is the 29th. Next time we meet is Thursday the 1st, and on the schedule it says you'll start the take-home portion of exam 1. And you can even start that now if you want. If you go into the modules, let's go back to the student view. So, modules, and if we scroll down where it says exam 1, there's take-home practice, take-home portion of exam 1, and there's a discussion where you are going to put issues that you have with exam 1, questions and answering questions here. And the discussion is worth 5 points. So it's significant that you participate here. Put in a question and answer a question. And the take-home portion of exam 1. So you can click on this and work through the take-home portion, and that's available right away. And it even has answers. I would work through the test without ever looking at the answers, and then at the end come back and check and see if you're getting them correct. Okay, and if you come back, look at the exam. When you try to go to the exam, it just says it's locked until the date and time of the exam. October 8th, we'll be taking it from 1:15 to 2:15 p.m. So the exams, we'll have class that day. We'll go 12:30 to 1, and I'll be teaching some new material. And then we'll take a 15-minute break, and then at 1:15 the exam opens up, and then you have to, what most students do is print out the exam, write on it, and then upload images of what they've written on. Any questions on how the exam is going to work? Okay. I also want to say that the homework has been graded up until 3.4, and you might see, I have a grade on 3.2, and I have a grade on 3.4, but there's no grade on 3.3. What's going on? Well, on every homework assignment, you need to look at the comments. But especially on the one that has no grade on it. And if that was the case, I'd click on 3.4, and I might see, I have to redo these problems. It looked like you were understanding except this group of problems. So instead of me taking points off, I'm just asking you to redo. I don't grade everyone, but I look at a sampling, a random sample of the problems. And so if I see that maybe there's just one problem I'm asking you to redo, or maybe there's a group of problems, and then you have 1 week to redo those problems. You don't need to upload the whole assignment. I've given you credit. If I just say redo just one problem, like redo number 22, all you have to do is rework 22, upload that one problem. That will replace the previous upload. I'll just be able to see the 22, but that will be fine, and then I'll give you credit for it. But if I see that it's still incorrect, I'll ask you to redo it again until you get it right. Okay, so then the objective is to get every student into a 7 out of 7 for their homework. And I'll just give you feedback until you get them correct. All right, now let's go to inverse functions. And we were doing this practice quiz stuff, and all right, let's start this. State the inverse action or actions. And so what I'm going to have you do is type this into your group chat. So, opening a window, state the inverse action or action. Climbing a ladder, state that inverse action or action. Just numbers 1 and 2. Type that into your group chat. Okay, and you can hit enter, see what everybody else has typed in. So these first two, pretty clear. Opening a window, the inverse action is closing. Window. Climbing up a ladder is climbing down a ladder. Now, let me tell you the point of an inverse. A point of an inverse action or actions is to totally undo the previous, so that when we're done with the first action and its inverse, it's as if nothing had ever happened at all. Completely undoes it. Open a window, close a window, whoop. You're back to your initial position as if nothing had ever happened. You climbed up a ladder, you climbed down, back to as if nothing had ever happened. All right. Now, number 3 starts to get a little bit more interesting here. State the inverse action or action. Go ahead and type it in. Entering a room and turning on the lights. Type that into your group chat. See how many groups we have here. 6. Okay. All right, check out what others have said. And group 6. What's the inverse action or action of entering a room and turning on the lights?
It would be exiting the room and turning off the lights.
Ah, now notice you did not, you said exiting the room and turning off the lights. All right, does everybody agree with this? Or is there anybody who disagrees?
I disagree.
Why?
Because you can't turn the lights off from outside of the room. You have to turn the lights off and then leave.
Ah, really? When we look really for subtle things, we see this very important point. When you have more than one action, to invert it, you not only have to invert each individual action, you also must reverse the order. Turn off lights. And exit room. Because when you're outside the room, maybe the light switch isn't near the door and there's no way to get to turn off the lights. So really key thing, we've got to invert the action. So Number 4, walking into a classroom, sitting down, and opening a book. If I did this without inverting the actions, I would have to, if I inverted each action without changing the order, I would have to walk out of the classroom but in a squatting kind of sitting position. Then I would stand up, and then I would close my book, but the book's position would have changed. It was on my desk in the classroom, and now it's got to be out in the hallway because so it doesn't undo the actions unless we also reverse the order. We have to close the book, stand up, and then walk out of the classroom. All right. So that's how we invert actions in general. And in math, it works exactly the same way. So we're going to go down to describe verbally the inverse of the statement. So the first one says add 2 to x. If I'm going to describe the inverse verbally, what's the inverse of adding 2 to x? Go ahead and type that in to your group chat. Don't hit enter yet, but just type it up. Okay, hit enter. See what others have written. Okay. Group 4. What do you have for number 1? Group 4, you got anything? Let's go to group 3. Add 2 to x. You can always say pass if you don't know which one to say. All right.
I think we'll pass. We haven't come up with anything.
Okay. All right. It can be a little tricky just figuring out what the directions really mean. If I'm adding 2 to any number, what does it seem to be the opposite of that? Or the inverse of that would be subtracting 2. Not the 2, but I'd say from x. So adding 2 to x, the reverse would be subtracting 2 from x. So for instance, if x was 10, adding 2 to 10 would give me 12. But subtracting 2 from 10 would, instead of making it 2 larger to 12, make it 2 smaller down to 8. Okay, so the next 2, go ahead and do multiply. Describe verbally the inverse of multiplying x by 5, and also do number 3. And type that into your group chat. Okay, group 1. What do you have for number 2?
This is Brianna. Would you divide x by 5?
divide x by 5. So, for instance, if you, and this is why we call it the inverse. If you take any input, like let's say 10, and you multiply 10 by 5, you get 50. Then you immediately do the inverse. Divide 50 by 5, you'll get back to where you started. Multiplying 10 by 5 and then dividing that result by 5, multiplying by 5, dividing by 5 will completely undo each other. You grow from 10 to 50 and then you shrink back down to 10. And group number 1, do you have anything? Same group, do you have anything for number 3? And you can say pass if you want to. I'll open this up to anybody. Subtract 2 from x, multiply the result by 3. What's the inverse of this?
This is Brianna from group 1 again.
Yep.
Would you add 2 and then divide by 3?
Okay. This appears to be correct. And that's exactly what I would say had I been in your shoes seeing this for the first time. But actually, it's wrong. Does anybody see what's wrong about this? You can tell me. Yes.
This is Lily. The order isn't reversed.
Very good. When there's multiple things, we had to also reverse the order. So we put those two ideas together, and the new one is going to be divide by 3 and add 2 to the result. Okay. And alright, so then we're going to wind up doing these things symbolically as well. And this is where we're going to pick up next time. Alright, so are there any questions or comments? Alright, so let me just highlight real quickly. You've got a quiz that's in the modules that's due tonight. The inverse functions, we have not gotten through all of that yet, but we are let me tell you, I'm going to change the due date for the spot check for the inverse functions, because we'll finish that up tomorrow, or the day after tomorrow. So I'm going to push back inverses a little bit, and we'll be starting to get ready for the exam fairly soon. And remember to look at the homework, especially if it's 3.4, anywhere from 3.1 to 3.4, and there's no grade on it. That means it's telling you to do some problems. All right. I will see you all on Thursday. Oh, and I wanted this feedback.
Thank you.
Pardon?
Bye. Thank you.
Oh, you're very welcome. Feedback. Was it just as glitchy today, or was it a bit better? If everybody could type in something in Discord. Was it sticking today? All right, we're seeing good. A lot better today. Beverly, still you got kicked out. Okay, so we've got a couple people that it was bad. Oh, and then another person still had a 10-minute chunk. All right, so somewhat better. All right, thank you much for the feedback. I'll talk to Comcast and see if there's anything more we can do as well.
I have a question.
Yes.
So, I don't have graded 3.1, but it doesn't have a comment on it.
You have no grade plus no comment?
Yes.
And your name is?
Sasha.
Sasha. 3.1. Okay, I see a comment. It says missing the.
Oh, okay. I didn't see it. I'm sorry.
Can you see it now on your screen?
On my screen, well, in the computer, yeah, but I can't see it in my Canvas one for whatever reason. It says that it has no comment.
No kidding. You can just see because of what I put on my screen.
Okay, yeah, I took a photo of it, and I'll be redoing those.
Okay. All right. How do you get to your in Canvas? You should hopefully be able to have access to those comments.
Okay.
So.
Shankin?
Yes.
I'm having the same problem as Sasha in my spot check of composition functions and another one.
That you can't see the comments?
Yeah, there's 0 grade and there's no comments. I can't find them.
Okay, and your name is?
Vanessa.
Vanessa? All right,
Yeah.
let me look back. Vanessa Baca, and at 3.1 spot check? Is that right? Because Vanessa, I'm seeing.
I'm missing practice spot check for composition of functions and the practice homework and the spot check for 3.4.
Okay, let me.
That's
All right, so the composition of functions is okay. Composition of functions, I haven't entered any spot check grades for that yet. So that's just I didn't realize that I should have done it this weekend. All right, that was my fault. I should have put that in. And then, so I'll get to that soon. And then, what was the other one? You said for 3.4?
Yeah, it's the spot check for 3.4.
Spot check for 3.4. And you have a 7 there. And then... All right, my comment says it's not 75% complete. You're not able to see that comment?
No, I can't see that in my grade book.
So you, in your grade book, there is that assignment and you can click on it, but no comment shows up.
Yes, that's correct.
All right. So anyway, I'm going to change your grade to 3 because my wife was helping me this weekend, and I said, you know, they get 3 points if they have 75% correct. And I'm looking at it, and really my intention is that if you have, you know, enough done that you can ask good questions, and it looks like you have enough. You're close enough. I'll give you the 3 points for it. So.
Thank you, Mr. Shankin.
You're welcome.
I'm sorry, I thought I had done the 75.
Okay. All right, but it's concerning that you're not able to read the comments. Okay. All right.
Mr. Shankin,
Yes.
you hear me?
Yes, I can hear you.
Okay, I'm sorry, I got kicked out and everything's being very choppy.
Okay. And you are? Your name is?
I'm Beverly.
Beverly. Ah, yes. Okay, and is Omar here as well? Okay, because there was Beverly. There was, I think, something that I wanted to go over with you, to make sure that you understood from the homework. And I think I'd asked Omar if he would stay after class as well. Are you here, Omar?
Mr. Shankin, this is Brianna. I also had a hard time. I didn't see any comments for my homework 3.1 and 3.4.
Brianna Baca. All right, so 3.1. All right, so are you in it right now? You're inside Canvas looking at it? And can you click on the 3.1?
Yeah.
All right, now when I click on my 3.1, but when I go to the speed grader, oh. All right, let me hit submit. All right. Can you see the comment now on 3.1? Brianna.
Sorry, I'm trying to reload it real fast.
Okay. Because what I'm thinking is...
No, I still can't.
You still can't. Hold on a second.
Yes, I just found it.
It's there now. Okay. I think what's happening is I have to hit the submit button and I didn't realize that. And for the comments. So I'm gonna have to go back and hit submit on all these to make sure that you guys can see the comments. All right, so we're all getting used to this new new way of doing things here. All right.
This
Yeah.
is Lily. I was wondering, when do we need to have our redone problems in by?
Typically it's 1 week, but I'll be flexible now because I didn't even hit the submit comments. So let's say at least by the, not this weekend, by the following weekend. But try to get them in as soon as you can after you see that there's something to redo. Okay?
All right, thanks.
You're welcome.
Thank you so much, Mr. Shankin.
Oh, you're very welcome. All right, and any other general questions before I talk with Beverly about some specifics in math? Okay. All right. So, Beverly, are you there?
Yes, sir.
Okay, and how's your connection? Is it a bad connection?
It's a little bit choppy, but I can just tell you something.
Okay, all right. So let's, let me come to your, there was something in one of the homeworks. Let's start with the 3.1. That was number 36.
Yeah, it was, I think, said
Redo 36.
is that one of the ones that I already turned in? Because
Yes.
I read something.
Okay, let me hit the submit button. So, okay, and yeah, now the comment's showing up. All right. So now that wasn't the one that was so important to me, though. I think what I wanted to look at with you, let's look at 3.2. Oh no, this is still 3.1. Sorry.
It's okay. That's the one that I redid those.
Oh, so you
today.
redid
That's-
these two. Okay, great, great. So, and are you understanding this?
I believe so. Yeah.
Okay, now I think your 32 looks negative 32, negative 5, and 33 looks good. Your number 18 is still not correct. Let's look at that one. Oops, sorry, Pepper. Let's look at that one together here. All right, and let me go to here so we get a fresh screen. We'll just call this temp. All right. If I have this function, what's my domain going to be for this?
I'm a little lost how to do domain from a function.
Okay.
Like I can easily do it from a graph or 2 points, but
So you're much more comfortable with that, but from a function is, okay, I get you. All right. So I'll come back to that in a minute.
okay.
The domain on this one is all real numbers. The domain on this one is something that's a property of x. Cannot take square roots of negative numbers. So x would have to be greater than or equal to 0.
All positive.
All the positives. That's right. Would the domain be on that one? Okay? And there's two things we have to avoid. We cannot have negatives inside square roots. And there's something about fractions. Do you know what?
The domain.
We're too choppy. I can't hear you. Say that again.
Is it that the domain, or not the domain, the denominator cannot equal 0?
That is correct. What x would cause this denominator to be 0?
5.
So what's the domain? X cannot equal
X cannot equal 5.
5. And if you were writing it in interval notation, it would look like this. All right?
Okay.
Okay. So, the problem that you had was kind of similar to this. It wasn't exactly this, but it's kind of similar. Now, what you would have to do to see what numbers x can't equal is you'd first have to factor this out. This times this gives me x squared. The two last ones have to multiply to be a positive, so it has to be plus and plus. And then, since the middle term is also positive, we keep them all plus. And then 2 times 1 would give you 2, and the two middle terms would be 3x plus 2x, 2x plus 1x, which would give you 3x. All right. Now, what's the domain of this one once you see it in its factored form? What's a number that x cannot be?
Would it be x cannot equal 3 or negative 3?
Okay, now if x was 3, it would not cause 0 to happen in the bottom of the fraction. 3 plus 2 would be 5, 3 plus 1 would be 4, and it's not really like 5 over here, because if x is 5, it causes the bottom of this fraction to become 0, which is not allowed.
Well, are there two different domains, one for x plus 2 and then one for x plus 1? Does that make sense?
You're on the right track. There's two different numbers that x cannot be.
So x is negative 2 or negative 1. X cannot equal negative 2 or negative 1.
Yes. That's it. And then if you wrote that in interval notation, You kind of think of it on the number line. Everything over here, everything between the two, everything over here. So it would be like this.
Okay.
All right. And let's go back. Two, 3.3. And
Yeah, I didn't get any comments besides the very first assignment that you turned in, or that you gave me feedback on, which
okay.
I haven't received grades for anything but the first 4 spot check.
Okay, so this one, 3.3, this is the one I really wanted to look at with you, with these intervals. Finding the intervals where it's increasing and decreasing. And so let's go over here. And 3.3, let me find that page in my book. 224.
You're a bit choppy.
Can you see my screen?
Yes, it's better now.
Okay. Is that 18?
Your voice is really choppy right now.
My
I
voice
can't
is really
hear anything
choppy?
that you're-
Okay. Let me bring up this. And okay, am I coming through now?
Yes.
All right, let's look at number 19. On number 19, tell me where this function is decreasing.
It's decreased from negative 2.5 to -4 and -2.5.
Now, where?
No. -2.5 to +1.
So what you're really telling me is this. When x is between -2.5 and 1, this thing is decreasing. Now,
Yes.
we also would state it like this in interval notation.
I didn't understand once like that because I was accidentally going off of the y-axis instead of
Yes.
the x.
And the problem with going off the y-axis is, like, suppose you said the interval from -1.5 up to 5.5.
That
You get 3 portions of the curve. It doesn't tell you where it's in, you know. So the only time you'll get a unique portion of the curve is if you take x coordinates, not y's. When you did it this way, from negative 2.5 to 1, you always get a single portion of the curve because functions have to pass this vertical line test. And so you'll only get 1 portion of the curve.
Yeah, and I understand now.
Okay.
Somebody else asked a question on that. I realized what I did wrong and was going to redo them and then turn it in again after I got back.
Okay, perfect. All right, well, let's just practice this on 19. Tell me where it's increasing.
It's increasing 4.5 to -2, and from +1 to, well, I guess it's not actually -4. It would be, it's increasing from, no. Yeah, it's increasing -4 to -2, and then +1 to +3.
Okay, now you see the arrow at the end? Means this thing goes forever. So instead of saying +1 to +3, we'd say 1 to infinity. And it means along the x-axis all the way forever to the right. Okay?
And then also from -2 to -infinity.
Would it go in this order? Like that?
No.
Which order does it have to be in?
E to -2.
So what goes on the far left here?
-infinity.
Very good. And then -2. That's right. And this would turn in interval notation like this.
Okay.
All right.
Again, wasn't thinking and going off of the y-axis.
That's right. You were kind of mixing it up. It looked like sometimes you were picking the x-axis number, and the next time you were picking the y-axis number. Yeah, we got to be consistent with the x-axis, and then I think you'll be good. All right. I think those are the key ones I wanted to go over with you.
Okay.
All right.
And then so my grade is actually fine besides redoing those and turning them in?
Right, yeah, because you're getting, and you'll get 100% on these homework once you redo those particular ones. So then your grade's doing good, yeah.
Okay, because on my end it says I have a 63.
63? All right, yeah, you'll get that up soon. Okay. Let me look at the grade book. No, that's the wrong one. Alright. 3. Why would it be telling you 63%? And grades. Oh. there was a 0 on 3.3, I don't think there should be a 0. It should just be blank. Okay. There we go. All right. From what you've turned in, you've got 100% so far. That's been graded.
Okay, thank you.
You're welcome. Anybody else? Any questions or issues?
I just had a quick question because my internet was being super choppy when you went over toolkit functions.
Uh-huh.
And
Oh, let me
we're
turn off
lost
the-
in